Next is about Hooke's law. You may have learned about Hooke's law in high school or in junior high school. Hooke's law states that the force and displacement, or the amount of deformation, are proportional. This is characterized by using the example of spring. This means that the relationship between forces and deformation acting on a spring is described by the equation F equal kx. We can see equivalent relationship in this material dynamics. Let me start with arguing about this from the conclusion. What is proportional? It is the relationship between stress and strain, which is described by the equation. This is the Hooke's law in material dynamics. The value of E is a constant called Young's modulus. Young's modulus is unique to each material. As an example, consider the case where the strain of a bar is 0.1 and 10%. The Young's modulus is a coefficient that defines how much stress is generated when the bar is stretched by 10%. So, the higher the value of E, the higher the stiffness of the material. The word hardness may not be used here. In material dynamics, the term hardness is not used to describe the magnitude of Young's modulus. Here, we shall use the term rigidity or stiffness. The higher the stiffness, the higher the stress to generate equivalent strain. Then, as mentioned before, this means that the Young's modulus is higher. This table enlists the Young's modulus of popular materials. Iron may be an example of a common known material. There is a type of iron that is called mild steel. Mild steel is available around us, and it is relatively inexpensive. Mild steel has a Young's modulus of about 200 and 210 gigapascal. In contrast, other example is resin or plastic. Compared to mild steel, resin has a Young's modulus of 2 to 5, which is only smaller than 1/30 of Young's modulus. What this means is, for example, plastic bends much more easily at less force. If you compare the bendability of a steel plate to that of a plastic plate, it should not be so difficult to understand. Here, we notice that it may not be correct to use the word softness to describe the bendability or deformability of a material. Anyway, plastic bends at a smaller force than steel. You may understand more clearly by imagining a bottle made from iron and plastics. A bottle made from iron is not easily deformed. For example, we have a pot that is used to keep coffee and other drinks warm. They are not easy to be crushed with our hand. This is because the Young's modulus is very high. In contrast, there are also bottles made from polycarbonate and polyethylene terephthalate. We may be familiar with them as plastic bottles. they have very low values of Young's modulus, which are only about 2 or 3. At their rigidities, they can be easily deformed just by pushing with fingers. Again, we say that anything with a low Young's modulus is less rigid. Plastics, for example, have a very low stiffness. Mild steel and cast iron have a Young's modulus of roughly 200 gigapascal. Keep just these points in your mind.